Mainly SigmaPlot is an application, you're aware of it. It is used for analysis and for graphing various type of scientific engineering graphics. You can use it for a lot of it. It's for the publication graph, which you will use it for your publications. Now come back to SigmaPlot. I just wanted to tell you a few things. When you install SigmaPlot, first of all, most of the people would aware of it already, and could be boring for some people, but it is necessary for some people. Those are newbies. So SigmaPlot, when you install it, it goes into C program files, X32, and SigmaPlot directory. But when you launch SigmaPlot, it creates a profile folder into your documents, and that's very important. That document folder has INI files and all initialization files in it, which helps for a particular user, because you could have multiple users on the same machine, so they can set their own profile and SigmaPlot, which creates automatically, and they can modify it later. And that goes into their documents folder under SigmaPlot. So from now on, after version 16, if we would have a patch, I'm not too sure if we are going to release it, but if there's a patch and afterwards there's a plan to move the profile folder to the upper level, means it will go into your C users directory instead of into your documents directory. And there's a reason behind it. The reason is that there is a OneDrive issue kept on coming back, and the people would have the OneDrive and their documents reside in the OneDrive. That cause sometimes the synchronization issues, and SigmaPlot slows down and sometimes stops working. And that's the reason that profile folder is moving above, but right now it is still in the documents folder. So that's what, just for the heads up, I thought I should mention it to you. So that was about the profile folder. Now, SigmaPlot has a utility, and it's called license utility. The people would be aware of. If you click help, and there's a license status, and that's what tells you that what license you would have it. Right now I'm running a network license here, so it says network perpetual, and that's my license manager, where the license manager running from, and this is the version. That's what the information you would have it. Sometime it says perpetual only, so that means it's only the local license. So that's the license information. And there's another thing is that the license type, if you would have to install a new license. So there are two types of licenses we provide. One is the product key, and the other one is the V2C file, and that's sometimes confusing. The product key is alphanumeric key, about less than 20 character long, and that's what you put it over here, and then you apply the license. But in that case, your machine has to be connected to the internet, and if it is not connected, then there is an issue. You won't be able to install the license. However, the V2C file is a local file. It's a big long file, and it has all alphanumeric gibberish binary things, which nobody could comprehend other than the SigmaPlot. So you need to select it, browse, and then select that file and click apply the license. So this is a different thing. So you need to actually locate the file. Usually sales send it out through the attachment as an email attachment, and you can save it on your desktop and browse it to that and apply the license. So there are two types of licenses that I thought I should mention it to you. So let's close it down. There is one more thing I need to mention it to you. License status. Under the license status, there is a license information. Sometimes we require, or the sales require you to send us the C2V file, which is the machine signature. It's just these two lines. Sometimes only one line, and sometimes it's only two lines of the code. This is the only signature we need, and you need to save the file and send it out to the sales. And then in return, they will provide you the V2C file and then you can browse it to that and select and apply the license. And that's how the license would work. Mostly network license works that way. Okay, so that's about it, about the license status. And if you have any questions, please, Torgrim, please let me know, because I have full screen, so I'm not looking at the chat window right now.
Yeah,
okay,
that's okay.
Perfect. So I think if you would have any question about the license, I can answer later. Now, if you look at the screen, this is the default screen of SigmaPlot, which has a data set. And then you have on the left side, you have the Notebook Manager. Notebook Manager is your main organizer, where you have everything. You have the notebook. You can have multiple notebook, and each notebook would have a section. Right now, section 1, so you could have a multiple section, and under section, you have the data. So data is the parent object for everything underneath in a section. So you have the graph, report, anything else, transform, or whatever you would have it. So that would be the part of the data. So in other words, you can have multiple graphs associated to one data, but you cannot attach one data to the multiple graphs. So that's how the SigmaPlot organizations work. Okay, now very important thing, under help, we have quite a few resources we have provided, and that is on the left side, you can see the help contents. If you click on contents, then it will give you the help contents, and it tells you various things, system requirements, all of that stuff. So if we go back in the search section, you can type something over here. I just type trigonometric list, and then it will give you the topic, and then you can open it up, and then it will give you the details of that. So that's very important, which is the user guide. It gives you a lot of information. Let's go back to the help again, and you have there's a tutorial also available. If I click on it, and there's a very tiny button over here. If you click on it, you'll see the lesson. All six lessons will tell you. If you have to go back again to learn about SigmaPlot, tells you a few things how to do that. So it will give you a very good start for the tutorial. Now we'll go with the SigmaPlot help. You saw that, and the tutorial saw that. Next thing we'll talk about the worksheet. The worksheet, what we have right now here, is called data, as I mentioned it to you earlier. And then you have this column title. If I select my mouse and bring it to the title, then it changes. You can see that it changes upside down arrow with the big blobs in it. And if I double click on it here, then I can type the title. So the SigmaPlot title is different than compared to Excel title. Excel title goes into the first row, but SigmaPlot title has a specific location where you can put the title. And then here you can enter the numbers and keep on entering. It goes down to the rows, and that's how you can enter it. You can also enter the titles of the rows here. If you want to type title over here, you can do that also. For example, my row. So that will be the title of the row. So that's how you can put the rows title and the column titles. Usually people use a lot the column titles because this is column oriented application, and the most of the thing goes to the title. Now, if I go here, click on the main button, I can click new, and I can open a notebook. I can click OK, so it opens another notebook. You can see notebook 1 was this one, and there's another notebook, and it always creates the default data. So you can also import the data. And the way you can do that, you can go file or click on the Sigma button and then file import, and then import the file. And you can have different file of types. You can all different type of files. You can see the Excel file, plain text, comma, delimited, MS Access, SPSS, the old version of SigmaPlot files, and SAS, Minitab, all different type of the data files you can import in SigmaPlot. So I can get out from here for now. So that's how you can import the file. You can also copy and paste the data. Let's say if I have this, I can just select this, Control C, or just right click, copy, and then come back over here. And then over here, I can paste it, right click, paste, and that's how you can paste that also here. So either from SigmaPlot to SigmaPlot, Excel to SigmaPlot, anywhere you can copy the data, or from any text file, you can come and copy the data into SigmaPlot. Now, one more thing you can see on the right, this data, let's minimize this one. You can see the data is right justified on the worksheet. If it is the right justified, it means SigmaPlot dealing it as a numeric data, number data. But if it is a text data, regression AB, you can see that this data, when you enter it, it goes to the left justified. Any data which is left justified on the worksheet, which is that it is non-numeric data. Numeric data is always the right justified. Okay, so this is a few basic about SigmaPlot, and I'm going to close it. I will go close the notebooks as well. It will ask me if I want to make some changes. I can close it, or I don't want to make any changes. So let's close them. Right now, there's nothing right now on it. Okay, let's go to help again. There is another resource we have provided. Other than those guides and help, we have the graphs, statistics, transform, nonlinear regression, macro data sets. This is all resource we have provided in SigmaPlot, and we'll use some data in it. Okay, so let me go to the statistics, and there's all sample files. I'm going to close it because this was open before. As you can see that there are various sections in it. So this statistics sample file, which create all of the sample files of the statistics test, which we use in SigmaPlot. For example, you can see the first section is the descriptive statistics. If I double click on it, it will open the worksheet. It has the group A, B, C, D. There are 4 groups in it. And if we were to run the statistics, so it will show us. You can go to Analysis tab, and then you can click on here, this drop-down list. You can scroll up, and then descriptive statistics. There's another way of accessing it. If I click on here, test, and then describe your data, then descriptive statistics. So it's a kind of, a group wise, it tells you. And here is it is non-group. All the entities you can see over here, complete list of the entities, and here it is in the groups. So if I click on it, again, what I did, I went over here. Either way, I select it and then click run. This is one way of doing it. And then it will bring up the dialog, which will ask you, where is your data? And so you can select your data. The way you can select it, you can click from this drop-down list. You can keep on clicking the data, group A, group B. So I inserted group B again, so it means I should have group C instead. I can double click on it to deselect it. So this is the way you can deselect your data. So there is another way of selection. I can bring my mouse over these 2 columns here and drag it to the right, and then leave it so it will be selected. So this is another way selecting all data. You don't have to go back to this list and select one at a time. Now I have all 4 columns are selected, and I click finish, and it will give me the descriptive statistics. Here it gives me all 4 columns with the title A, B, C, D. These are the column A, group B, group C. These are all A, B, C, D, 4 groups, and then the size of the column. Here you have 14 rows, most of them are. So there are 2. B and C had the missing data. You can tell right now missing data, it is reporting that this one and this one missing data. You can tell right now this one is missing and this one is missing data. You have the mean, standard deviation, standard error, confidence interval of the mean, so on and so forth, all range, maximum, minimum, median, skewness, kurtosis, all kind of statistics you're getting in here. There's another thing you can tell over here. If I click on options, once I have this descriptive statistics selected, I can click on options and it gives me the report options. So these are all statistics are selected by default. I can clear them up and I can select only the one I wanted. You can do those also, or select all the way it was by default and get all of the data selected and run the test, and that's how you can get it. So these are the options are given for each test. If I click on it, select any other test, for example, t-test, then if I select it, then it will give me the option for the t-test options. So this is very basic kind of statistics. You can get it from here. Now, this is another important thing for SigmaPlot, which we offer, and you may not see in any other application. We call it Advisor. And if I click on Advisor, it gives me the here Advisor wizard, and it asks me a very simple layman questions. It doesn't expect you would know the statistics, and especially for the scientists and the researchers, they may not spend the time to learn the statistics, especially going to the college or getting the four-year degrees to learn statistics. They don't want to worry about that stuff. They want to mind their own business and just want to have something help out to them, and that's what this advisor is for them. So it asks you very simple questions. First of all, describe your data with basic statistics or summarize the data in categories. Number 2, compare groups of treatment for significant differences, predict trend, find correlation, blah, blah, blah. So these are all different kind of questions that people would have it. Most of the scientists, I have noticed, the people, they compare the groups of treatments for significant differences. If I select it, then I can click next. The next question, it will ask me, okay, how are your data measured? Is it by numeric values, by order ranks, by proportions, or number of observations or categories? In categories, for example, male, female, you know. So since I have the data by the numeric value, I can select it, the numeric values, and then click next. And it's, do you apply more than one treatment per group, per subject, sorry? You can have yes or no. For example, no. And then click next, then it asks me how many groups or treatments are there. If you have 1, 2, 3, so let's say we have 2 groups. We are comparing. Finish, it will tell me what to do. We suggest that you should run t-test. And if I click on run, then it will pop up the menu to run the statistics. So let me close this data and let me open the data for unpaired t-test, which is this is the data. So what I did, I just dragged it from the corner and I slide it. So that's how I can, resize the worksheet. So I have 2 groups here, male and female. This is the same data, by the way. This 3 columns, these 2 columns, and last 2 columns, they're all same data. This is only the format is different. The unpaired, this is the raw data. You have the male and female. The 2 groups are defined in these raw data, whatever they're measuring, anything. And in these 3 columns, you have the same data. For example, the size. Here's the size of the first 8, and the size of the second column 7, and the mean of these 2 columns independent, and then corresponding standard deviation. If you have this format of the data, you still can run the t-test. And this is also very famous, which we call it the index data. And this is the same data. This is format in index way. And this is a data column, and that's the gender and response. So if I click on, again, analysis, I can select, I have selected the t-test already. I can click run, or I can go over here, test, and I can go to compare the 2 groups, t-test. either way. So here the data format. If I select drop down, if I click on this drop down list, raw data, index data, mean, size, standard deviation, mean, size, standard error. So, or it's actually the one more additional standard error also it supports. Instead of this column, if you would have the standard corresponding a standard error, you should have selected this one and proceeded with it. So let's do the index data. And index data, if I click on proceed, even though I have selected this one, but let's go index data next, and then I'll ask me. So these are two columns which are already selected incorrectly, so I can deselect them because my group is actually column 6 and data is column 7. You saw that I just double click on these to deselect them. And if I click finish, here's the report. So this is the timestamp, and it tells me very important thing. It did a few things to the background. So it actually checked the normality test in the background automatically and equal variance test, which is Brown Forsay test. So both tests are passed, and it provides after that you have the, the regular, what you call it, simple statistics for the male and female. And then you can see it's using the Welch. There are two tests. You will get it over here. One is the student t-test and one is the Welch t-test. So both tests are provided here, and you could click under options and you could have selected over here. You can see that. So results, you can have that both student t-test, Welch test. You could come down here, and then under the results you could have selected, or by default they selected both. So I just wanted to show you, and then there's a confidence interval table. Okay, so the t-test over here, it gives you the t-value and then degrees of freedom. Now it is also giving you the two-tail p-value, two-tail p-value, and then the conclusion. This is also important for some people, that there is a mean value. There is a difference in the mean value of the two groups is greater than would be expected by chance. So there is a significant difference. There is a significant difference between the two groups. So whatever the groups we have selected, these two, male and female, so there is a significant difference. That's what it is telling you in the report. Usually you have to draw your own conclusion based on the p-value or the t-value of the t-statistics. Here you have that. You can see that over here. This is less than 0.05, so that's how you can draw your conclusion that there is a significant difference between these two groups. And same thing, you get a different t-value, minus 3.19, 3.19 over here. So don't worry about the sign, because the sign is because it's taking the difference, and the difference of mean, because it came negative over here, so that's why. So it doesn't really matter the t-value is negative or positive. The actual p-value which makes difference, and the p-value is always between 0 and 1, and if it is less than 0.05, most of the time this is how you have the alpha value selected. And this is also you have under the options over here. You can see that over here, the alpha, the p-value to reject is 0.05. So that's conclude for the t-test. It tells you what to do with the t-test. And now I can go to the advisor back again, just to see if I can have something else to do with it. If I can select again, I want to compare the groups or treatment for the significant differences. I select it and then go to next. And then I have the numeric values. Okay, next. Do you apply more than one treatment? Let's say for right now, no. Do you have 3 or more groups? Yes, I have 3 or more groups. Click finish. We suggest you should run one-way ANOVA. So it tells you what to do, all right? So let's find the data for one-way ANOVA, and this is my data for one-way ANOVA here. So let's minimize this one. And over here, let's bring up this thing. Okay, so you have species A, B, and C. These are the three groups. And we have a different format, similar as t-test. So these are the three columns, corresponding columns, which is a different format, which tells you the size, mean, and SEM, standard error of the mean. And then this is the index data. Most of the time, people would have the index data, but we can accommodate the raw data as well. You can see that. And over here, I can click again test. I can go to compare many groups, and I can click on one-way ANOVA, and then it will bring up the dialog. Or I can click over here and select one-way ANOVA the way it is selected, one-way ANOVA, and click on run. And it gives me the dialog to select the data. So this time we have three columns already selected. The first three columns already selected. We can go with the raw data, and you can see that the columns are selected, A, B, and C. You can deselect them. You know that if you double click on that, it will be deselected, and whatever the column you would want, you can select that. So I can click finish. And now, very interesting thing, you can see that it comes up in another dialog. It says multiple comparison options. And it gives the multiple options for that, which is the Holm-Sidek, Tukey, and Dunnett's, Bonferroni, so on and so forth. Now, what happened actually in the background, it did quite a few things as it did for the t-test. It actually tests the normality and equal variance test, and most likely it is passed, because otherwise you would get a different dialog. Not only that, it found that significant difference. There is a significant difference, but where is the difference? And that's where the post-hoc test, or so-called multiple comparison test, comes back. So you need to pick up one of the tests and then click finish. So the way normality test passed, equal variance test passed, and then you have the statistics, and there's a conclusion. The significant the difference in the mean value among the treatment groups are greater than would be expected by chance. So there is a statistically significant difference. Now the thing is that these are the three groups. So it only tells you there is a significant difference, but where is actually the difference? Is it between A and B, between species A and B, or B and C, or A and C? And that's where we had to run the post-hoc test. And in any other statistics package, you have to run everything separately. So not only you need to conclude your results, but you need to run those tests separately. By knowing each step, what you need to do with it. Now you can see that it is actually ran the all pairwise comparison test. And here is the result. You have the species B and C. There is a significant difference. Yes. There is a significant difference between B and A. Yes. But there is no significant difference between species A and C. You can see over here. So these are the corresponding p-values, t-test, difference of the means. And that's the important part. And that was the Holm-Sidek method. You could have picked up any other one, Bonferroni, Tukey, or whatever. So you would come back with a very close conclusion, the one which we have right now over here. So that's the good part about SigmaPlot, that you don't have to worry about. And now I can show you in practical that, okay, here, let's see. Okay, here is another ANOVA. Now we'll see how the SigmaPlot actually helps. If I have already one-way ANOVA selected, I can click run. I can pick up the raw data or maybe the index data. Let's do the index data next. And then this is my group. And this is my data. Finish. See what happened here? So SigmaPlot not only it's actually walk you through by hand, and then if you may run into some issues because of your data, then it give you the right path. Okay, what to do with your data. This time it actually it found out the normality was failed. So for this particular data, the normality test is failing. So the regular parametric path, which we did in the earlier one-way ANOVA, it is not too appropriate. You could do so anyway, because if you can say no, then it will run the normal ANOVA. But it is suggesting you to run one-way ANOVA on ranks, means it is asking you because the normality is failed. So that's why it's telling you it's better to run it ANOVA on ranks. So if I go yes, then of course it found again the differences. And here it's actually giving you the next dialog. Then it has different tests, the Dunn's test, Tukey test, SNK test. And you can click finish, selecting any of the tests and click finish. And here it is the conclusion and the report. So now you're not getting the mean values, you're getting the mean median, and that's actually comparing the ranks because it actually ran the Wallace ANOVA on ranks for you instead of running a regular ANOVA because the normality failed here. See, the normality test failed, and that's why it just suggested you. So that's why it is hand-holding you to walk you through exactly the right path when you run a statistics. That's why it doesn't require any prerequisite or college degree to go through a regular statistics. You would have to run in, you need to run to. So similar, we have the difference. We have the conclusion, and we have the multiple comparison. So there is a significant difference everywhere. So you can see that meter 10 versus 1, 10 meter versus 5 meter, and I'm not sure what is the data is that could be there's some kind of lake. They find different I don't know different things in the lake at the different depths, 1 meter, 5 meter, and then they do find it 10 meters. They found that something different, and they want to compare them. So something like that. So that's how maybe the data came up. Anyway, so that was interesting to see that how the SigmaPlot behaves when your data is not normal, and it tells you what to do with it. And over here, so you have the advisor also tells you a lot of things in it. Okay, so the other thing I wanted to show you, so we ran all of the reports here. You can see that here. So the t-test report, we had it here. And we had the one-way ANOVA report. If I double click on it. Okay, the good part, if I right click on here, then I can create the results graph. So which we didn't do that. I mean, you could have done it for all of those, but I just wanted to show you. So you still can do results graph. I can click on it and it gives me an option, different options to do the results graph. So the bar chart, the column means, if I click OK, so it gives me you can see the species A and B, C. So this is the bar chart. It gives me a basic bar chart. And I can select, there's another way of selecting it. Once you have the report open, you have to have the report open, by the way. And you can click on here under the SigmaStat, see under analysis, you have the create graph, results graph also. The same thing will bring up. And you can select by shift, pressing the shift key, all of them, and then it will give you all of the graphs. Okay, this one is the histogram. It's asking me left binding, close. So this all of the graphs, it's probably a normal probability plot, histogram. And then this is the scatter plot. The column means all different plots. You're getting it over here if you select with the shift key and all of the graphs. So this is how you can get it, even though you have run that. So before closing, so you could go back to your reports and then create the results. Okay, now we can go with the so I can give you about 2 minutes break to write down your questions, and then I'll come back to you.
Yes, I will use those 2 minutes to introduce my colleague and the licensed experts for our data analysis tools here at Alfasoft. He's sited in our Swedish office in Gothenburg. Mehmet, can you hear me?
Yes.
Yes.
So thank you, Mohammed, for the presentation. And I mean, we know SigmaPlot is a very popular tool in Europe, especially in Scandinavia. We have many users who are enjoying SigmaPlot in the Nordic countries and in other countries as well, of course. I can maybe start with some questions that I received before the meeting, just like while we were waiting for other audience members to write theirs. We can, for example, let's talk a bit about the advantages of using SigmaPlot as opposed to using, let's say, SPSS. I'm using SPSS as a name here because it's a very well-known statistical tool as well. Let's talk a bit about the advantages of SigmaPlot over SPSS. And maybe let's say Excel because like it's also used in analysis, but of course it's not as advanced as SPSS or SigmaPlot. Let's just talk a bit about the advantages of SigmaPlot over other statistical tools.
I'm sorry, Mehmet. I think Mohammed needed a break, 2 minutes. Maybe he's fetching a cup of coffee, so he will be back in a minute.
All right. I can repeat my question later when he arrives back. But in the meantime, like if we have users of SigmaPlot in the audience or potential users, people maybe tried it before, but they're not really using it actively. In that case, like they're considering different options. I encourage everyone to write their questions so we can ask Mohammed.
Yeah, is he back, Mohammed?
Yep.
Are you?
Yep, I'm back.
Yeah, Mehmet has a question for you.
Okay.
Thank you for the presentation, Mohammed. Just I was so in short, my question.
We still have something more to go. So
yeah, of course, no. In the meantime, I can just ask. So maybe you can tell us a bit more about how SigmaPlot compares to other big statistical tools such as SPSS. I'm using SPSS as a name here just because it's like one of the most well-known established software tools for statistics. And also it would be great to see how, for example, SigmaPlot 16 compares to 15 in case we have users in the audience who have 15 and then who are trying to figure out whether it's worth moving to 16 or not. So in that case, it would be good to show what 16 can do as opposed to 15. Like what are the advantages of upgrading, for example?
Okay, perfect. Okay, the basic question I already answered to you before. Remember what I mentioned it to you when we saw the report. The main part about In SPSS, you have to run everything separately, and sometimes you have an option to run the normality test along with the ANOVA. But the other packages, the SAS or other packages, you need to run those things separately. So first you need to actually get your data, and then you need to find out which path you have to take. Either you have to take the parametric path or non-parametric path, depending upon if your data is following the normal population or not. And these sort of all of the things, you need to figure it out beforehand. But SigmaPlot does it for you, and then it runs the normality silently in the background, normality test. And then if it is passing, then it gives you the parametric path and actually runs the normal statistics. And we saw the previous example, the Kruskus-Wallace test came up. Even though we were trying to run the parametric ANOVA, it is guiding us better to do the non-parametric ANOVA, and it guided us to the Kruskus-Wallace ANOVA on ranks, and that's what we did. So first thing, it actually runs the normality in the background for you, and then it finds if there is a difference. If there's a difference, then it actually the follow-up, it give you the option to run the pairwise comparison, which it gives you an option over here, and then you could run the pairwise comparisons. So it make it the workflow, make it so easy. And then once you have the report, you can just select the results graph and you can pick it up. You don't have to pick up any data over here. It just does it for you automatically, and it creates those graphs. So that's a very nice workflow in terms of comparing the other packages. In other packages, you have to learn, you have to know a lot of things. Now the next question about what is the difference between SigmaPlot 15 and 16. So I can show you a few things. Let me close down. I mean, if I go close down, it asks me to close down everything, but I just want to show you, just you can use those, whatever you can select, you can close down. Let's say if I right click over here, I can go close notebook, then it asks me whatever the make I have the changes, do I want to keep them? I don't want to keep those changes. I can say no, and then it's closed everything. So I can go back to the health. And this time I want to show you something over here, macro data and violin plot. Okay, this is my data for the violin plot. It has 3 columns. The people, they may want to run it. They can go under the tools and then select the violin plot here. And it gives them the option to, it already knows how many columns you have. And as I told you that the data, right justified data is the numeric data, and that's the data you need. You cannot run anything non-numeric data in here. And it won't give you if you have the missing data also. So there is no, if there is a missing data, then it would not give you any violin for that particular column. So it's very simple one. You have the graph dimension, whatever the dimension you want to select. So you can actually override this thing if you want to. And then the violin gap, the fill color, if you can keep it by default white, or you want to have a gray fill color or dark gray. And then you can even add the box plot. Let's not do it for now. If I click OK. So it gives me the violin plot. So this feature is not in version 15. So this is one of the difference over here. This feature you can find in version 16 only. Let's go back again and then click on it here. It actually gives you the results over here as well. So because we have because it counts as many columns you have, you just need to use the first 3 columns. And let's keep it white, and let's go and add the box plot this time and click OK, and they can see that here is that graph with the box plot. Nice violin plot with the box plot inside. So again, this feature is not in SigmaPlot 15. The other thing is the butterfly plot you have here. The census. 2021 UK census. There are two categories in it, and the label. If I click on here, you can see under tools again is the butterfly plot. Click on it, then I can pick it up. So it already knows the count, the first column, the second column, the third column is the label column. And then I can select the grayscale or any other color. For example, this one, I can go with a color here, royalty. I can rotate the labels, and then bar width, I can change it to, right now it's 75%. And rotate the label if I want to. I can enter any value between 0 and 90. I can just right now, let's keep it as is. And here is that your, let's make it a little larger. I mean, I can select that here, and then I can drag it, make it bigger to look like it, or there is a, I just need to do like this to show you. So usually you can see the graph. You have the title, and then you have this is the axis. You have it already sitting, kind of, works with the axis and the color. You can change the color as well into the different scheme. You can pick it up, and then we can go to different one and select this one, for example. Then it comes back a different color scheme. Anyway, so this is the butterfly plot. This is not in SigmaPlot 15. Let's do one more thing I wanted to show you. Okay, let's go back to the help menu again. Let me select this graphs, and I can go select the scatter, the error bars. Let me create the graph over here. And I want to create a line and scatter plot with the error bars. I select this, create graph, line scatter, and here. And I have the worksheet columns for my, the error values. And I will pick up not all, but just 2 XY pair, that's fine. And this is my, I want to do 2 ways. Let me close this. I want to do the multiple error bars rather. This one, I did actually single one. I could have added another one, but I just wanted to show you. I can show you if you need to, but this is the one I want the same thing. X many Y rather, because not one pair. I wanted to pick up multiple pairs. So X, this is my scatter, this is my error, and this is another scatter, and this is another error. So if I can finish it, you can see that error bars, right? Now, if I don't click on it, I can go to the area fills. I can select the band. You can see over here what I did, area fills. And then from the direction, I can select the band. And this is the error bands. You can see that it is not in SigmaPlot 15. So that's also a new feature in SigmaPlot 16 as compared to, you can see that the error bands, and you can change the error band colors if you need to. You can go back and then change the fill colors. Let me, different scheme, let me change it to tones maybe. Okay, so anyway, you can play with the graph properties that people would already know. And that's another feature with SigmaPlot 16 would have it and 15 doesn't have it. So we have provided and same thing we have, if I were to go and then run regression, we have a few minutes here. Let me show you. Let me enter it by hand. Let me call it X, and let me call it this one Y. And let's go to analysis and let's do the regression wizard. I want to run the standard curves. Standard curves, and then I want to run the 4-parametric logistic. This is the equation, by the way. So I can select my X column and then Y column. Next. Yep, perfect. Create a graph. Select I want 95% confidence in prediction bands. Okay, did you see that bands around it? So the red one is the prediction, and then the blue one is the confidence band, and that was not the part of it before. So it is the new in SigmaPlot 16. So that answers your question, and actually I ran the standard curves as well. But let me do it again just to show you. This was the this is I ran it manually, but there is another thing we have in the tools. I had this simple and EK and then standard curves. If I click on it under the pharmacology, and then it gives me the dialog for parameter logistic, whatever I want, and it already knows. So do I have the log format? I don't have the log format. Let's keep it everything as is. And here's the graph. So the standard curve, there's another way of doing it, the standard curves. Anyway, so now let's come back to, I wanted to show you another thing. So because we are doing the researchers today and scientists, so maybe they would be interested in another type of plot, which is the, what we have call it, okay, I can go back again, help, and then I can select this macro data. I think so, I already have it here. ROC curves, yep. So this is the ROC curve data I have. I can go to the tools, and then I can select this ROC curves, select it, and it gives me the dialog. So these are all different modules are provided in here. So I can add these 3 columns. And keep everything as default. If I want to create the post result test, I can, but that's fine. Click OK. You can see that. So it actually ran the ROC curve. So this is how we started. This is the ROC curve. This is the dot histogram. It actually did it for you. Then you have the sensitivity and sphericity. That is another statistic that people, they are looking forward to. And then there's another report in here, and that it gives you the ROC area curve, all of for the 3 columns which we have, and then the ROC curve comparisons. So we almost done, almost 7.
Yeah, I was going to just jump in to say we probably need to wrap up. Before we wrap up, I have one final question, which is like when you were showing all the features, all the graphs, all the visualizations, I realized like once you click on generate, it generates the visualization instantly almost. So it's so fast. But I also noticed, like at the moment, since we are only showing the demo, we don't have many data points. I was just going to ask. I was wondering when you were showing, is it the same speed we can get when we have like 1,000 lines of data?
Yeah, 1,000 lines of the data
work
is
in
not.
General?
It's 1,000 line of the data is not a problem. The problem would be when you have the million lines of the data or 100,000 plus. The reason is that what happened, this graph always talks to, well, I can show you this another thing, the good part about it. Graph page. Okay. This graph always talks to the worksheet. Any little minor changes, it sends and then it updates. And what happened for a smaller data set, that is instantaneous right away. But if it is a large data, then it takes a longer time, a little longer time, and then you won't be able to do anything. It may try to draw it again because it sends something. And that is the reason, because it's keep on talking. There is a way of disconnecting something. For example, there's a stop button over here under graph page. There's a refresh and stop. You can stop it. So if you were to make some changes, you can stop it so it doesn't redraw. Then you can go into the graph properties or do anything else which you're waiting, because it is redrawing it because of the large data set. Got it?
This is such a good tip to know, actually. Thank you very much for sharing
Yeah.
that. I think we need to wrap up. Torgrim, what do you think?
Yeah, I see the clock has passed 4 o'clock. So yeah, I think it's about.
Thank you, Mohammed, for the great presentation.
Thank you very much. Appreciate it.
Thank you, Mohammed.
Thank you. So all right.
Yeah. Thank you, Mohammed, once again, and thank you to all the attendees. The day is over, but we have 2 more days, and I know, Mohammed, you will be coming back on Thursday.
Yep. That's right.
Engineering focused SigmaPlot. So I'm looking forward to it.
Okay, great. Okay. Thank you very much. Thank you, everyone.
Thank you. Have a nice day, all.
Sure.
Bye.
Bye-bye.